Okay, we're ready for the next video here. Video 4. We're going to actually get into finally creating your first ladder logic program. So I just want to start out real briefly before we actually get into the software, but I just want to say ladder logic is what we're going to be dealing with here. And what is it? It's a graphical programming language used for programmable logic controllers or PLCs. It resembles electrical relay logic. It makes it intuitive, for electricians and engineers. It uses rungs, which are horizontal lines that represent control logics. And so this really got started because in the olden days they used to use a lot of relay logic, hardwired relay logic, and so a lot of your drawings looked a lot like this. So it was kind of a natural progression to use ladder logic programming in the first PLCs, and I would say it's still probably the most popular version of programming. Some of the basic ladder logic elements, and we're going to see these more as we get into the software. But contacts, they represent inputs like push buttons or sensors. You have normally open contacts, like what you see here. They close when they're activated, and normally closed contacts, they open when they're activated. And so you can see the little difference in what they look like. Coils represent outputs like motors or lights. An output coil, hey, you got these parentheses here. That's the symbol for an output coil. Those activates an output when the run conditions are met. And then also we've got timers and counters. Those are the basics. There's more than that. There's other ladder logic elements, but this is really the core of it here. Again, here's kind of an example of some of these all together. Let's see, let me go ahead and get a little bit better pointer going here. But you've got, here you've got a normally open contact, normally closed contact. Here is an output coil. This has actually got a motor output here. It's labeled with a description. And here you got a timer. This is a 1 second time base. Right now there's no preset. Normally you'd have a number in here that's not zero. Like if I had a 5, that would make that a 5 second timer. This is a counter, and you can see C5:0 is the counter that counts up. CTU is an up counter. There's also down counters, but you can see the preset is 500. What that means is this count every time this is energized, it will count up 1 until you reach 500. Once this counter reaches 500, this done bit would turn on. And then this end rung just means that's the end of the program. All right, so what we're going to do in this video as we move along, we're going to create a new project in RSLogix Micro Starter Lite. We're going to define some inputs and outputs, some I/O addressing for an input and an output. We're going to add some ladder rungs with some logic for some control operations, and then we're going to use, and simulate or download. We're going to be using the emulator and not an actual PLC, but for all of our testing. And we have a practical example like a motor start stop circuit where we've got a start button with a normally open contact, energize an output coil. We're going to have a stop button in this circuit with the normally closed contact that will de-energize the motor. And we're going to show you how to use some latching logic to keep the motor running even after the start button is released. All right, so let's move into the software. All right, we're going to open up the MicroLogix software here. Let's go down and find the Rockwell software. And let's see where we got it here. RSLogix Micro English. There we go. So we're going to start a new file. I'm going to go ahead and maximize that. Basically, we start a new program here. We're going to select the MicroLogix 1000 just for testing purposes. No big deal, really. And starting out, the way this software works is ladder 2 is basically the first ladder program that gets created here. And this is the one that we'll be working in. And I typically just use these icons here across the top. You've got, we need to add another rung. So what I can do is kind of click on that. There we go. Let me get that in here. There we go. I'm going to insert that and rung. We're going to do like a motor start stop. So I know I'm going to need a normally open contact. I'm going to need a normally closed contact. I'm going to need to branch around that here. Now I'll explain this here in a minute. I'm going to need another normally open to seal in or latch. And then we'll have an output. So this could be my start button. And just for testing here, I'm going to go ahead and select I0. Whoops, let me type that right. I0, 0. And we're going to call this start button. All right. And then we could say the next input, I01, could be our stop button. Like that. I'm going to go ahead and comment it. So you can add descriptions here for the address. I've never used this one for an instruction that much. I usually just use the address here because I want it to be tied to that address. And then the latch, that could be an internal bit, internal binary bit. We're just going to select B300 for starters. All right, so we're going to do that. B300 is going to be we're going to just call it a latch bit for now. Actually, no, I want this to be the output. I'm sorry. We want this to be the output. We're going to say that this is like driving say a motor. The motor, just call that motor, and then this will be our output here, 000. So the idea here is that, all right, let's see if I can go ahead and verify this rung. Okay, good. The rung's verified. I can save this. I want to go ahead and give it a name. For now, we're just going to call that motor start stop. Motor start stop. We could call that really anything and just do a save. And so the idea here is this will be the start button. This is a normally open contact, and if it's an input, so if it's wired to an input, the first input on the card, it's going to close. This normally open contact will close. This is called like your power rail. So think of this as your power here, your voltage, and it would pass through this contact when it closes. And so this is a normally closed contact with a stop button. So think of it as the voltage would go all the way across here to the output to the motor. And this drives an output 000. And what this does is it latches. So once this output coil gets power, then this normally open contact will close. When this coil energizes, this contact for the motor closes. And what that does is it seals it in around there. It's basically seals in around the start button because this is only a momentary button. When I press the start button and I take my finger off of it, this goes from closing to going back to its normally open state. So now the voltage basically is going around the start button out to the motor. And that is how that seals in. But what we can do is I can download this to the emulator and actually test this out. All right, so I got the emulator open here, and I'm going to go ahead and try to remember where I put the file at. I think I put it under my documents folder, I believe. And maybe not. Okay, let me look further. All right, so here I have it under this folder here, motor start stop, and you can save these basically wherever you want to. Okay, we got to compile it first. All right, so I actually need to go back to the file. I'm just going to double click on the file in the folder. Okay, that was something I forgot to do. All right, so as far as downloading the emulator, I've got the emulator open here, and I've got RSLinx open, the RSLinx Classic Lite, and you can see that I've got the MicroLogix shown in here. Should be able to go to system comms and do a download to it. Okay, let's see what we got going on here. I need to probably set it up in RSLinx first. All right, so in RSLinx here, we want to make sure we've selected this. I've already selected it, but the driver that we're using here should be the SLIC 500 DH45 emulator driver. And you can see I've already done that. I've actually already got it, and that is running. And then the station number, I guess by the default, should just be 0 for that. But this would allow me to have that set up here in the emulator. Now going back to the emulator software here, I can open the file again. Let me make sure I open that. Now here what we've got is motor start stop. Main file is 2. We're just using ladder 2. The starting rung is 0. The ending rung is 1. So that looks right. All right, so should be good. Destination station. Oh, we did not insert that, did we? Okay, I think it's 0 is a duplicate. Oh, yes. Okay. Let's try station 1. All right, so that should be set up there. Do I need to check anything on the controller? Okay, I've just got it set up as a MicroLogix 1000 now. Processor node 1. Okay, I think everything is probably good there. All right, so now I do see a MicroLogix 1000 when I do the check on the comms. And it's actually asking me for a download, and do I want to go online? There we go. Now, when it first comes up, it's probably going to come up. It's probably going to come up in the remote program mode, which is normal. Should be able to try to switch it to run. So we're actually running the program. Now, if you look at that, my power rail here, I'm going to maximize that, is green. I should be able to, I don't think I can, oh, it does let me toggle it. So this is regularly actually good. So I can toggle this bit. I don't really have any real outputs here. But you notice how I toggled it back off. That would be the same thing as me taking my finger off of the button. When I did that, we're still latched in, as I mentioned. The motor output is on, so our motor should be running. This start button contact is open again, but notice when these are highlighted green, this means that they're passing power. So this normally open contact is now closed, and of course this normally closed contact is in its natural state of being closed. Now, if I want to stop the motor, all I have to do is press the stop button. And when I press the stop button, it has the exact opposite action of the start button. The start button is normally open, the stop button is normally closed. So when I press the button, I toggle that bit on, notice what happens. This normally closed contact opens, and now I've broken the connection from my power rail out to the motor. So now the motor is off. You see it's no longer highlighted green. And then if I take my finger off of the stop button, that would be the same thing as this going back to its normally closed state. And now if I want to start the motor again, I can toggle the bit, and there it is. The motor would be on currently. And even if I take my finger off of that start button, it's still on. The motor is still on until I press the stop button. And when I take my finger off the stop button, this goes back to normally closed, but the motor remains off. So that's basically a really simple motor start-stop type of circuit. So if you ever hear that mentioned in ladder logic, this is the basic way that that's set up.